Here we're going to introduce our first trick, namely letting dv equals dx, or dv equals 1 times dx. It's not really a trick, but it's something I like to point out. For example, suppose I want to integrate the natural log of x plus 3 from minus 2 to 2. This doesn't look like f of x times g prime of x because the g prime of x is going to be 1 here. So integration by parts works here if we just take g prime of x equal to 1. So let's let u equal the natural log of x plus 3 and dv equals dx, or 1 times dx if you prefer. And now du, or du dx, is 1 over x plus 3, and this means du is 1 over x plus 3 dx, and v is the antiderivative of 1 dx, which is just x. So now using our formula, the integral of u dv equals u times v minus the integral of v du. And notice I always write the formula so that I can fit things in there to reduce any human error I might make. So we have the integral of u, the natural log of x plus 3 dv dx, equals u times v, which is the natural log of x plus 3 times x, evaluated between minus 2 and 2, minus the integral of v du. So that's x times 1 over x plus 3 dx. Now, I've colored this last integral in red because it requires a little work to figure out what's going on there. It requires a substitution that's maybe not too obvious. So, to calculate this integral in red here, we're going to use the substitution w, say, equals x plus 3. And in that case, x is equal to w minus 3. So then we're integrating w minus 3 over w, and of course dx equals dw here, so that's pretty easy to integrate. And of course, since it's a definite integral, we must substitute for the endpoints. So we have w of minus 2 equals minus 2 plus 3, which is 1, and w of 2 equals 2 plus 3, which is 5. So we get the integral from minus 2 to 2 of x over x plus 3 dx, when we convert everything, is the integral from 1 to 5 of w minus 3 over w dw. Now, breaking this up, this is the integral from 1 to 5 of 1 dw, which is pretty easy, minus the integral from 1 to 5 of 3 over w dw. And of course, this first integral is just w evaluated at 5 minus w evaluated at 1, which is 5 minus 1, which is 4, minus 3 times the integral of 1 over w dw, which is the natural log of the absolute value of w. And of course, we evaluate that at the endpoints. So our final answer is 4 minus 3 times the natural log of the absolute value of 5, which is the natural log of 5, minus the natural log of the absolute value of 1, which is 0. So now, going back to our original integral, we had the integral from minus 2 to 2 of the natural log of x plus 3, and we saw that that was x times the natural log of x plus 3, evaluated between 2 and minus 2, minus this integral in red, which we've just calculated. So substituting our answer for the integral in red, we get x times the natural log of x plus 3, evaluated between 2 and minus 2, minus our final answer for the integral in red. Plugging in the endpoints here, we get 2 times the natural log of 5 minus minus 2, which is plus 2, times the natural log of minus 2 plus 3, which is the natural log of 1, minus what we got for the integral in red. And in all, when we tidy up, that natural log of 1 becomes 0. We get 2 times the natural log of 5 minus 4. Minus by minus gives me a plus times 3 times the natural log of 5. And again, tidying up a little more, we get that that's equal to 5 times the natural log of 5 minus 4.